Science Galaxy. Welcome to our channel Science Galaxy, where we learn science in simple ways. Don't forget to like, subscribe and share the video.
Now let us discuss about projectile motion. What is projectile motion? When an object is thrown from this point, it rises to a height and then comes back. This parabolic path of the object thrown is called projectile motion. It is due to two kinds of motion, horizontal motion as well as vertical motion. Consider an object which is thrown from this point with a velocity u. Its vertical component would be u sine theta. If this is taken as theta, this would be u sine theta, while this would be u cos theta. So we have two components, vertical component as well as horizontal component. Vertical component is u sine theta and the horizontal component is u cos theta. For horizontal motion, let us consider about horizontal motion. Horizontal motion means along x-axis ux, initial velocity would be ux, means u cos theta. Ax, acceleration in x direction, is 0. There is no acceleration in the x direction. Acceleration only in the y direction due to gravity. Vertically we have uy is equal to u sine theta and ay is equal to gravity force. Now we know that distance is equal to, horizontal distance is equal to Sx, means horizontal distance. That would come out to be ux into t plus 1 by 2 ax into t square. Here we are applying that distance or displacement is equal to ut plus half at square. In place of ux we would write u cos theta, because our horizontal component ux was equal to u cos theta into t plus acceleration was 0. Whole this term will become 0. So Sx is equal to u cos theta into t, that is ut cos theta. Now we would calculate Sy is equal to uyt plus half ayt square. Uy is equal to u sine theta into t plus half ay is equal to minus g into t square. From here we could find that Sy is equal to ut sine theta minus half gt square. Now Sx was ux into t, or we can say that t is equal to Sx upon u cos theta. T is equal to Sx upon u cos theta. Also we know v is equal to u plus at, so Vx is equal to ux plus ax into t. Ux is equal to u cos theta plus ax is 0, so whole of this term will become 0. Vy is equal to uy plus at. What is uy? Uy is u sine theta minus gt. Minus gt because ay is equal to minus g under gravity force. So Sx was u cos theta into t, or we can say that t is equal to Sx upon u cos theta. Also Sy came out to be u sine theta into t minus half gt square. Here we would return the value t is equal to Sx upon u cos theta. and we would get Sy is equal to Sx tan theta minus 1 by 2 g Sx square by u square cos square theta. This is the equation of parabola, hence it covers parabolic path. Under two forces, under two components, horizontal component and vertical component, the object moves under a parabolic path. How had we proved it? We have proved it using Sx. Sx was equal to u cos theta into t, while Sy equal to u sin theta minus half gt square. From here we found out the value of t to be Sx by u cos theta and returned this value t here, and this equation became a parabolic path. So under projectile motion the object covers parabolic path. Now let's find the maximum height for the parabolic path. What would be the maximum height? Maximum height would be this. Initial velocity would be u, but the final velocity here would be 0. V would equal to 0 here. So we know about v is equal to u plus at. In y direction, Vy is equal to uy plus ay into t. Uy is equal to u sin theta. Ay is equal to minus g into t. But Vy will become 0 because at maximum height velocity becomes 0. When the object rises from this point to this point here, it faces an acceleration, but then also its velocity becomes 0. So at this point the velocity is 0. So Vy is equal to 0. Uy is equal to u sin theta minus ay is equal to minus g and into t. So t is equal to u sin theta upon g. From this point to this point, the object takes the time of u sin theta upon g. Again from this point to this point, the object will take same time. So we can say the total time of flight would be, time of maximum height is this, and total time of flight is 2t, because it has risen and again fall, is equal to 2t, that means 2u sin theta upon g. Maximum height, it has been risen through. Maximum height would be equal to, we need to find the maximum height, means this. This is again under y component, so we would write that Sy is equal to uy into t, but uy is equal to u sin theta, so u sin theta into t minus half gt square. Sy is equal to u t sin theta minus half gt square. We would write t to be u sin theta upon g, which we already calculated. Time for maximum height. Time for maximum height was u sin theta upon g. So we would write, in place of t, we would write u sin theta upon g. For maximum height, for covering maximum height, the object moved from this point to this point. During this point, the Vy is equal to uy plus ay into t, and sy is equal to sy displacement, where s is displacement, is equal to uyt plus half at square, but uy is equal to u sin theta uyt plus half ay t square, and ay is equal to minus g. And time, we know that time for maximum height is u sine theta upon g. We would return the value of time here and would get the maximum height to be u sine theta whole square upon 2g. This is the maximum height covered by the object under the projectile motion. Under the projectile motion, this is the maximum height. Now we would find out the horizontal range. What is the horizontal range? Here the horizontal range is the distance of this to this. This is our horizontal range. Here it is x component, means horizontal component. So we know Sx is equal to ux plus half ax t square, but ax is equal to 0. Acceleration under x-axis is equal to 0. So Sx is equal to ux into t plus half ax into t square, but ax is equal to 0, so whole of this term will become 0. Ux is equal to, what is ux? Ux is equal to u cos theta and time. Now for horizontal range, this is not for maximum height. For horizontal range, the total time would be required. For maximum height, only this much time was required. Now, for all the horizontal range, the whole time of flight would be required. So we would use, in place of t, we would write 2u sine theta upon g. Here, t is capital T, the time of flight. So in place of ux, we would write u cos theta. In place of t, we would write 2u sine theta upon g. And Sx would come out to be u square sine 2 theta upon g. Also we know if sine 2 theta is equal to 1, then the maximum horizontal range would be at 45 degree, because sine 2 into 45 means sine 90. Sine 90 equals to 1. This is the maximum value of sine theta. Sine could have maximum value as 1, so this would be maximum at 45 degree. Maximum horizontal range would be Sx is equal to u square upon g. This sine 2 theta has become equal to 1. Now we will try one more question on this projectile motion. Man stands 490 meter above the ground. So man is standing 490 meter above the ground and throws a stone with speed 15 meter per second. He throws a stone from this point at the speed 15 meter per second horizontally. Not like this. It would be horizontally, but slowly it would cover half parabolic path. Find the time taken by the stone to reach the ground and the speed with which it hits the ground. Now, we know Sy is equal to uyt plus half ayt square. Uy, we were throwing it in the horizontal direction only, so no components. It is like this. U is like this. So ux is equal to u, while uy is equal to 0. Had our component been like this, then we could write ux as well as uy. But here uy is equal to 0 and ux is equal to u. So Sy means displacement in the vertical direction is equal to uy into t plus half ayt square. What is Sy? Sy is 490. What is uy? Uy is 0 into t plus what is AY? AY is 10 or 9.8. To be more accurate, acceleration is 9.8 into t square. From this equation, we could easily find out t, which would come out to be 10 seconds. Now we would use Vy is equal to Uy plus Ay into t, and Vx is equal to Ux plus Ax into t. We need to find out the speed when it hits the ground. Speed at this point. It is moving like this. It would have two components, this component and this component. So we need to find Vx as well as Vy. Vy would be equal to Uy plus Ay into t, where Uy is equal to 0, vertical direction, and acceleration in vertical direction was 9.8 into time. Time we have already calculated to be 10 seconds. Vx, what would be Vx? Vx would be Ux plus Ax into t. Ux is equal to 15. Ax is equal to 0 into t. Vx is equal to 15 meter per second. Our velocity. Here we have already find out this component as well as this component. Now the resultant would be, we need to find out this. We know about this as well as this. This component and this component both are equal. This component are equal. So we need to find out this, and this equals to this square plus this square according to Pythagoras theorem. So V square would be equal to Vy square plus Vx square, or we can say V would be equal to under root Vy square plus Vx square. Vy we already find out 15 meter per second. There is no acceleration in the x-axis. So if initial was 15 meter per second, final velocity will also be 15 meter per second. Vy, initially in y-axis velocity was 0, and now it had become 98 meter per second. From this we can find out the velocity, resultant velocity, when it has just reached the ground, is equal to 99 meter per second.
Thanks for watching the video. I hope you like it. Don't forget to like, share, comment and subscribe.